Hello again. I am Miss Barbara from John Marshall High School. I am one of the math intervention for high schools. And today we're doing topic 3, lesson 9 on graphing. In front of you, you have two graphs. You have a graph A and graph B. The independent value is your year, which is on the x-axis. Your dependent value, which is on your y-axis, is the population in thousands. Now here is our dilemma. Number one. These two graphs show the population growth in a certain time between 1994 and 2002. The local Chamber of Commerce created Graph A, an environmental group that wants to discourage a manufacturing plant from building in the town created Graph B. Tom thinks that the population is growing quickly based on Graph A. Marty thinks the population is growing slowly based on Graph B. Francis thinks both graphs show the same thing. Who is right? Now, looking at the graph by yourself, what is a sure way of finding out who is guaranteed to find out who's right? Let you think about that. Did you think about it? Now, if you said find out which each coordinate is on the graph, you are correct. So what we're going to do, we're going to graph A first, and we're going to figure out what's the coordinate for each of these points. So let's go here. Let's make this smaller. Okay, so this is 1994, and that is 10. So we're going to put year is 1994, and it was 10,000 people in population in 1994. Let's look at the next graph. This is counting by ones. We notice that. I'm going to put this on the bottom. This one is 1996, only one step above, and that's 11. So in 1996, the population was 11,000. Oh, parentheses always go on your points. Okay, let's move that here. Let's put that over here. Let's look at this point. This point was in 1998, and it says 12. So parentheses in 1998, the population was 12,000. I'm gonna go on this side right here. In this population, in 2000, the population was 13,000. What did I forget? Parentheses, that's right, parentheses. And that was 13,000. Now, the last one in 2002, the population was 14,000. Okay, so those are our points for those person right there. Okay, let's go over here. This point is 1994 to 10. So that's easy to read. But we have a dilemma here. 10 is here, 20 is here. So what's between 10 and 20? What do you think about that? If you said 15, you are correct. So I'll put a 15 here. This is a marker. You don't have to put it there, but I'm going to put it there as a reminder that this number here is 15, which means these points right here are less than 15 and between 10. So they're between 10 and 15. My first point is 1994. And that was 10,000 people there. Move it over here a little bit. Now this point's a little bit above 10. I was able to squeeze 4 points in between here, but not getting 5. So I'm going to guesstimate and say right here it is 1996, and this was 11. Here I'm going to guesstimate too, because guess what? I have 3 points on my line between 10 and 15, and one of them is not 15, so this one got to be 12, and that's in 1998. Well, let's check at this one. This one in 2002, the population was 13,000. And in the last one, which is this point right here, and I'm putting it this way. Let's fix that back. That looks much better. And right here, the population was 2002. 14,000. You look at our points, they're the same, aren't they? Let's check this out. This is for the first point for graph A. This is the first point for graph B. This is the second point for graph A. This is the second point for graph B. This is the third point for graph A. This is the third point for graph B. And so on. We're just going to keep on doing this. And as you can see, they have the same points. Today, let me do this last one. So they have the same points. Today, you're going to learn about consistency of being consistent with your graph. X-axis and the y-axis do not have to be the same numbers or the same spacing on this word. There's a new word for us called scaling. Let's go into page 2. In today's lesson, you will focus on the following highlighted goal from this topic. Make graphs from tables. Last time we met, we talked about input, output values. This time, you're going to make a graph based on the table. So you need an input value. You need an output value. Okay? By yourself. Find information, then make a graph with a partner. When both of you have finished making a graph, compare them if your graphs are not the same. See if you can figure out whose graph is correct. Now, here we have our scaling. We can go back to our lesson preview because I want to make sure that we understand our directions. Okay. Scaling is an important skill in graphing. Each axis should have the same scale that makes sense for the data. Some students believe that the scale for x-axis and the y-axis always has to be the same. In other words, they think that if you count by twos on the x-axis, you have to count by twos on the y-axis. But this is not true. The scale can be different on each axis. What is important is that the x-axis has a consistent scale and the y-axis has a consistent scale. So let's go back to our first example. They had different scales. This one was counting by ones in years. This one was counting by ones for the 1,000 by the population. This one was counting by 10,000s. Okay, they're consistent. They're not the same. That is why sometimes the graph it might look different, but these are the same graph, same data. Just they decided to use a different scale for the y-axis, which is a population in thousands. Let's go back to page 3. Okay, complete questions 1 through 5 in the student activity book. Work on your own, then check your work with your partner.